Greg Leonardo is with us today discussing building solutions in Azure here on the Azure DevOps Podcast.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Happy New Year. I'm your host, Jeffrey Palermo. You can go to www.azuredevops.show for older shows and show notes. And today our guest is Greg Leonardo. Greg is a cloud architect helping organizations with cloud adoption and innovation. He's been working in the IT industry since his time in the military. And Greg is a developer, teacher, speaker, and early adopter. He's worked in many facets of IT throughout his career. And he's the president of TampaDev, a community meetup that runs #TampaCC, Code Camp, an Azure User Group, Azure Medics, and various technology events throughout Tampa. Greg, hello. Welcome to the show.
How are you doing this fine new year?
I'm great. It's a great January. We're only 7 days away from New Year as we're recording. So yes. 2019 is off to a fast start.
Yes, sir.
Well, you and I have known each other for some time, but for the listeners who are not familiar with you, could just give us a background of what your career has been like. How'd you get into software, and what's been your journey?
Well, my journey becomes interesting because I spent some time in the military after I got out of high school, and then after I got out of the military, I went back for my associates in computer engineering, and then I went back to school to get my bachelor's in electronic engineering. So I'm an actual electronic engineer by trade. So I worked my way up through, building servers, network business analyst, architecting networks, things like that. And then I moved over to actually developing some software to program these routers and switches and stuff. And that was my beginning of my dev arena. So I worked my way through development and did some dev work all the way back up to enterprise architect, then moved over to cloud architect when the cloud became available. So it's been a very fun and unique journey to get here.
Awesome. Yeah, we have one of those things in common with being in the military. And I think at the Ignite conference this past year, we were talking about vets in tech, and they had a whole different whole section of the conference talk about including various groups that are typically small groups, and one of those is vets in tech, and I think that group is kind of decentralized. It's not very well organized right now as far as at the conferences in the community. So that was an interesting discussion. But you have a brand spanking new book out on the market. Tell us about it.
Well, I wanted to check something off my bucket list. And write a book, and I wanted to share my experience on what my journey was to Azure. So I wrote a book on building solutions in Azure, and I wanted to make it to where guys starting out in Azure as well as guys that were familiar with Azure would gain something from the book. So I put little tidbits and things that I learned as I began my journey. But I really wanted to get more people involved in Azure, and that's really where the book started and came from, was, just getting more people, into it, things that you can do with it, and kind of teaching them not to be scared of it. Cause how everybody gets, it's just new. It's not scary. So,
Yeah. Well, even though Azure has been around, what is it, 12, 13 years?
Yep.
But of course, Azure started out with just a few PaaS solutions, which we really don't even use today. It's been totally redesigned just from a user experience offering. But as far as the rock solid architecture of the data centers and the network of data centers around the globe, that's over 12 years old. Massive investment. Man, I can't even imagine how many dollars have been spent building those things. But the software on top of it has just become phenomenal.
Yep.
How did you decide what things to even cover in a book about Azure, which would be so massive?
Well, it was really more of looking at the practicality of business development, right? I mean, you and I work in a field to where we support, businesses and end consumers. So it was really taking that approach to say, hey, how can I get started in Azure, or what are some things that I need to know about supporting business solutions? Because, even though Azure's been around for 12 years, there's still a lot around the adoption of how Azure actually works and the things that you can do with it. And, unfortunately, through my career, I've seen people misuse a lot of different things in our technology arena and then, constitute them as failures simply because they didn't understand how to use them. So it was really getting people into the arena of saying, here's how you can understand how to use something like Azure. Here's how you look things up that's different from what you would normally do from an internal on-prem perspective, right? I mean, guys looked at things, from a simplistic perspective and said, hey, I've got a bus on my network, so I want to do a bus in the cloud, and they immediately go to service bus when that's really not what they were doing or what they really needed to do to solve the problems, because functions may have solved the problem a little bit better, or logic apps may have stepped in to solve things a little bit better, but they didn't know about them because they did a one-for-one lookup and said, okay, I'm just going to do this and do that. And and there's 100 ways to skin a cat, as you and I both know, in Azure. So, it's really, kind of giving people the helping hand of, when you go research things, how do you do that? How do you find out the better way to solve something rather than just the old prudent way of solving it? So it's kind of, discovering all the new things in Azure and giving people the understanding of how to find them and what they should do when they're architecting the solutions, and not just simply look at Azure as they did for their local data centers and stores and stuff, and get out of the PaaS arena and looking at serverless and discovering things that are a wee bit different. Like you said, or like we talked about, there was people are scared of the new, so they don't particularly understand it, and then they don't know how to use it. So then some people will attach to new, and then they completely just drive down a facet without truly gaining an understanding behind it. They just want to get it done because it's in a business arena, and we all know that business arenas are dictated by delivery dates. So things get to be tough to learn. So it's kind of focusing people back in on how they can learn under those same constraints.
And just before we dive into it, where can people best find the book?
It's actually out on Amazon. So if they just Google Greg Leonardo on Amazon, that book should come right up.
All right. So let's jump into what the high points are. I think you started with architecture and how to think about that.
Yep. And that was kind of the biggest arena of the book was, teaching people how to find and discover things and not always think that one way is the easiest way to solve any solution, but to challenge yourself to find different ways to solve those solutions, in turn to cover your cost, right? I mean, you and I both know that the biggest struggle with Azure is people don't understand how to control costs in Azure. It's not a physical thing where you go buy a server and you pay $250,000 and then you have a data center, that you've got all these different fixed costs. Azure, in most cases, isn't a fixed cost element, and it scales a little bit differently, and it offers you things that you don't have to do. Like, I can scale out servers now, so if I have load and my site goes down because of too much load, I can immediately increase it back up without having to wait for servers to come in and stuff like that. So it's really giving people, how you should structure things that you should look at around making decisions for scalability, how you don't just want to take code that you ran inside of your own organization and just move it to the cloud, because that comes with its own set of caveats. You want to cloud enable your code. You want to make sure it's scalable. You want to make sure it's leveraging app insights, because you don't have access to the infrastructure like you used to. So a lot of people will move this stuff out and then they get stuck in the arena of supporting it. And, it's really giving them the understanding of how to get the things out there properly so they can support them properly.
Yeah, that's a good point. The cost element, I think every listener who's ever attached a credit card to an Azure subscription, or probably any of the cloud providers where it's dynamically charged, has seen firsthand how, just go and you go and turn something on. Then even if you're testing it out and then you forget to turn it off, and then at the end of the month you look at the bill and it's you got to control that. It's on you to budget and then make sure what you've provisioned.
Right. And even us cloud guys have made that mistake. I mean, one of my horror stories back in the day is they used to give us a little segment of like $250 a month. And I turned on an ASE environment because I was going to go through what an ASE environment was, and I was doing a blog post on it. In and out of a day, it burned through all my 200 credits and shut the site down.
Yeah.
So I couldn't go back out and delete it, because if you remember back in the day, you couldn't delete resources when the subscription wasn't active. So I had to wait for the next monthly cycle to come up, and I forgot when the date was. In and out of a day, it ran my subscription out again.
Yeah.
So I had to call Microsoft after that and been like, look, I've been trying to shut this down. I did turn it on, and but I've been trying to do a blog on this thing, and they were like, well, we'll go in and fix it. So,
yeah.
We went through all of those headaches. So.
All right, acronym police for ASE, just for people not familiar.
That's app service environment. That was the old way of doing isolated applications for PII and sensitive data environments.
And the new way?
The new way is just isolated applications. You now have an app service plan that isolates and it hides all of the infrastructure that you used to have to manage in the ASE environments.
That's a good point. A lot of people are, and certainly our customers, don't really know the whole structure and the ins and outs of how a web job and a web app is structured, and then the functions, and then there's this other thing called an app service plan that's
right.
Neither of those. On the architecture subject, can you give our listeners the rundown of how they need to be thinking about these different building blocks?
Well, and that's kind of the bigger key. When you're looking at web apps, we refer to app service plans as VM-backed resources, right? We call them VM-backed, which means everything on Azure has to have a compute cycle or some sort of compute associated with it in order to run. We all know that. Computers with Azures didn't change. It's just your level of visibility did change. So app service plans are physical elements of resources that you're assigning to any resource in Azure that fits under an app service model, which are functions, logic apps, web jobs, app services, cloud services, all the different arenas that sit out there. Those are physical backed units. They come with a pricing standard structure that's broken out from a subscription perspective, like $39, $49, $59 a month, stuff like that. You then have things like functions that come with a consumption based, and functions, logic apps, and event grids come with a consumption-based model, which is you pay for what you use. So you don't have a monthly sunk cost. You pay per usage, which I think is like you get 1 million transactions for $1, and then it's like 1 million transactions for another $1. But that comes with its own set of caveats and understanding that you have to understand that those are now shared resources. They have a cold startup time. There's things that are associated with them that can be a headache if you don't understand what it means. Whereas then you would want to take and use an app plan to back it so that you had your functions in a hot set or, always on scenario. So there are different cost structures, and we even break out the cost structures across data repositories. I mean, DTUs, RUs. I mean, there's a bunch of terms that go out there. When you're talking relational databases, DTUs come into play, which are data transfer units that are how SQL in turn builds itself, and those DTUs are a function of CPU to IOPS to RAM in the back end. So it's how they figure out all of this structure to charge for. RUs are associated with, like a Cosmos DB or schemaless environment. And those are request units. Those are where you pay for the amount of time it takes to get the data query to run. And if you go look at your data queries when you go against something like Cosmos, you can actually see how much that query cost. There's a query cost piece that comes out of that'll tell you, it costs $1.75 to run that query or something like that. So these are a lot of things that people need to understand. I mean, I'm not just going to go app services. I've seen people put Cosmos out on want to use it, and then they run up a $30,000-$40,000 bill per month because they didn't understand the RU structures or things that needed to go in to get that data or query that data, as they went through. Which schemaless is great, but it just comes at a cost.
So let's pick apart the architectural elements with the most common ones. So let's start with the web application. You want to run or you've developed a web application, you have one, and you want to put it in Azure. Let's talk through the options and how someone would choose one option over the other.
Well, for looking for Azure, there's several ways in today's day and age in order to do that. Some of the most easiest ways that a lot of people do from a lift and shift perspective is IaaS. They'll just move their entire box structure out there that has IaaS running on it, and then they will just dump their applications in like they normally would on an internal infrastructure side. Then from there, you have a general migration, which is containers. Containers have the ability to run the websites in them, especially core apps and things like that. Now, IaaS and containers become more cross-cloud compliant. So what ends up happening is now you don't have to worry about where you set the infrastructure, right? You can move it in and out, and it's not very specific. So I can move it to AWS, I can move it internal, I can move it external, so I can maneuver things around if I need to. Now when you get to something like an app service and using an app service plan, that's more synonymous to Azure. So that becomes more of you're going to, go all in on Azure and put your app services that way because all you're deploying is the website. Now that comes with a caveat, meaning that's only how you deploy it in Azure. You can do the same thing over an AWS or internal or any of that stuff. It's simply how you deploy it. So, like I said, there's several ways to get at these things. But at the end of the day, you have to pick the right one for what you want to do and how you want to maneuver your support. When I sit down with new customers that are just coming in and they don't have an IT shop, I may direct them to, only, do everything in an app service layer to where they can make their deployments and they have less interaction because they don't have to manage the infrastructure and doing patching on servers and things like that. So, it really comes into pick the right option that suits the build that you're trying to do.
So let me ask about those three options. So you mentioned just spinning up a VM and doing it just like you would anywhere else, or containers, or the app service option for a web application. We'll talk about the other components later. So with previous guests on the show, there doesn't seem to be a consensus or an appetite to tell the broader community to go and move your existing applications into Windows containers just yet. Because our audience is all .NET developers, and they have they're building new things on .NET Core for sure, but every one of them has a slew of existing applications. And so everyone's kind of wanting to know, okay, when should I really spend some time learning Windows containers, and when should I just kind of watch what other people are doing? When does it go from bleeding edge to cutting edge to now it's ready to adopt for real for the masses?
Well, I look at things in today's day and age. You and I both know how quick the cloud moves, right? So adoption now is in microseconds. It's not into months and weeks like you and I used to come up through the chain, right? Somebody put out a new processor, new core, new server. You and I had to play with it. We had to go, download it, figure out the things that we can do. We don't have that anymore. So I look at things from an adoption perspective to with the square peg round hole principle. You go out to your clients and you analyze what they have, and you have to look at the gaps between what their knowledge is. But you have to direct them in such a way for what they're able to absorb. So you look at something like Windows containers. If my clients are looking to be more container structured and they want to be able to maneuver things in and out of their organizations and be cross-cloud compliant, then I would direct them towards containers. If they're only care about one cloud provider and they just want to attach to Microsoft, then I would go app services or IaaS, depending on which one they could absorb. I really believe the discussion is what can an organization absorb? And I think one of the big struggles, especially from developers and cloud architects, is when to understand how to direct a client to do something, right? So you have to look at the caveats behind what they're able to absorb. If they can't absorb, what you're trying to do, it doesn't matter what kind of architecture you put together or where things go. So I'm not scared of Windows containers. Windows containers to me are a very simple thing that is a self-contained, that is very easy to add to projects. And it gives people the flexibility to be able to maneuver their applications across separate cloud providers. You see it more used, Jeff, in things like healthcare applications, right, that have to be up 100% of the time. While Azure and AWS and Google are really good at keeping their infrastructures up, they do take hits, right? You can't have those hits in a healthcare market. So containers become much more of a bigger talk in that arena, because now I can take that container and also deploy it on AWS and deploy it on Azure, so that if Azure takes a hit, my AWS containers pick up and keep rolling.
Well, I think that's absolutely true on the Linux side. I haven't found anyone yet who has gone all out on Windows containers. Everyone seems to be doing smaller things and then waiting for Microsoft to start using it for their own stuff. And we were told at the beginning of last year, it'll be by the end of 2018. And then I think in the fall, the Ignite conference, there were some people bantering around sometime in 2019. I mean, it's out there, and there's some YouTube videos and things on it, but there's no real big push, and I think they're still working on it. And so for the masses that are thinking, okay, I'm hearing about this, when should I go through it? I mean, the tooling's not even there for Windows containers. There's nowhere in Visual Studio, for instance, to be able to say, hey, I have an application. Yeah, go ahead and deploy it to a Windows container. So if the tooling's not there, then listeners are thinking, what should I do now?
That's not an overly true statement. There is a way in Visual Studio to add a Windows container. You can choose Linux or Windows. They did put that in. A lot of the adoption, comes in when I look at containers, is because Linux came out earlier and people have such a wider breadth of that, that when you introduce things, it becomes a little bit more cumbersome, right? Where I've used Windows containers is things like when I want to re-implement Service Bus, or I want to put a function into a Windows container because I don't want to deploy a function to a function app in Azure. I want to deploy it to a container. Then I would use a Windows container or something like that. Usually the containers that I'm doing today are really branded around when I want to take an Azure resource and redeploy it somewhere else, if that makes sense.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So that's the web application side. Now, everybody also has batch jobs.
Right.
Or some offline job runs on a schedule, a trigger, or queue, or whatnot. So talk them through the architectural options in Azure when they're staring at their job of some sort and they're thinking, okay, how should I move this to Azure?
Right. And that comes with that's one of those things that's a dual-edged sword. Most of the batch jobs that I've looked at are the hundreds of millions of things that come in. So I usually use high processing compute in Azure. To where you would use Azure Batch or something like that you would stand up and tear apart, as needed be, to process things, or you may leave them up and running. Now, for some lower end job functions, I may use something like a web job or something like that, dependent on what it is. But one thing people need to be cognizant of is that Azure is a web app by structure, right? Which means it adheres to all of the different timeout things and stuff like that. So if you don't take into account that, you're running this in a web environment, a lot of people battle through timeouts and things like that. I've seen guys try to run, functions to do a lot of these batch processing, and that's really not what functions were designed to do. I know they've gone more with more durable functions, and they've made functions run longer and stuff like that. But that's just really to appease the masses. Sometimes you really need to take into account what you're trying to do, how you're trying to do it, and build in the right solution. And that may even be, building a VM to do your batch processing. I mean, it really comes down to what you're going to absolve when you head over to Azure. But like I said, most of it is Azure Batch, using high compute. And we use the processes usually that tear up and tear down, so it saves cost. Because these environments are very expensive to stand up and leave running all the time.
That was a good point you made on functions. What is the current default timeout?
It's like 60 seconds, I believe.
Yeah, so that's a big difference. Someone has a batch job that forget the ones that take hours, or in some of the banks, that take all night. But even if it's something that runs for 30 minutes, that's well over 60 seconds. And so when thinking about options, it's easy to cross off Azure Functions if you've got something that without serious design changes, it's just going to run for 30 minutes.
Yep. And that's the big thing. A lot of guys want to like jam this stuff into Azure, and then they try to use the Azure bits to accomplish it, but they work differently than what they expect them to work like. So, I was at a client where they did that. They had a function that ran a 30-minute batch job, right? And the function kept failing because it would go off hook after 60 seconds. And they just tried to increase the timeouts. And I'm like, no, you have to re-architect the batch job, in order to report back to the function in a given amount of time, so the function knows to keep standing up, waiting for its response. I'm like, it's like being on hook. You're not going to sit on a phone call with nobody saying anything to you for 30 minutes, right? You're going to want to know that somebody's still there. It's the same process when you look at Azure. So it's getting people to understand that, things run a little bit different. You need to cloudify, as they call it, or cloud enable your applications when they go up, just so that you're able to gain the benefits of what Azure can give you with the fact of computes and do things. Because one of the key things is we did a little bit of rewrite on that job function, or that job that they were doing, and then in turn we got the thing to run because we could scale out the middle portions that did it. It was down from 30 seconds to about 2.5 minutes to run. So there's things that you can do to increase that. So we saved in cost by not having the resources needing to be available for all that time, but only for 2.5 minutes or 3 minutes.
So ignoring IaaS, because I think that's the obvious option, you can always run stuff that's running now on a Windows server can run in Azure on a Windows server. But you've mentioned functions, you mentioned Azure Batch. What's your opinion of web jobs?
Well, web jobs are the earlier versions of functions. Believe it or not, functions are the next evolution of web jobs. Web jobs were a way for them to overcome the ability of needing to run Windows tasks. Remember the old Windows tasks that we used to put in the task manager? That's what web jobs are really there to do. They were there to give somebody a transition over to it. And functions is the serverless / consumption-based model of that, which was the next evolution. If you go look at functions themselves, they inherit all of the web job functionality as the core usings in all of the functions. So you can see that they're just part of that. So it's the next evolution.
So what is it that makes functions such a higher price point than web job?
Well, the web job's the higher price point because they're VM backed. Web jobs cannot work without an app service plan backing them and stuff like that. Functions are more consumption based. So now I can go in and flip it on its side and say, I just want this function to run, and I can pay $1 a month versus $39 a month for the cheapest, app service plan. So that's why, functions to me give you the options to say, I want to be in a full consumption base, or I want to have VM backed. One of the things that, I've always talked to Microsoft about is that Azure to me has been more of a compute as a utility. So it should be more of a utility model versus a model for predictability, right? So they go out and they go, oh, this app service plan is going to cost you $79 a month. That's not how we look at things from the perspective of when we do electricity. You don't go to your electric company and go, I want to pay $100 a month for this level of electricity, right? We go in and we pay for what we use. I'm looking at Azure as being more of that plug. I'm just going to plug my application in Azure, and then I pay for what I use. So that's where I think that eventuality is going to be.
Is it electricity, water, gas, or is it telephone, internet?
It is all of the above. It is a utility.
But on telephone, you don't pay, at least for a home phone, and a lot of cell phones are unlimited now anyway. You don't pay for the number of calls. So cell phones have gone from consumption-based.
Right. Well, yeah, I remember. Yeah.
Okay. For your and I, first cell phone, it was very.
We paid by the minute at one point.
I remember the 200 minute per month cell phone that I had. My very first cell phone. That was. Yep. I mean, it was wow. I could make a call anywhere.
Yep. I remember my first cell phone was I paid 25 cents a minute. Yeah. So I didn't have a plan. So however minutes I used, I paid for.
So those have gone from consumption based to fixed monthly all you can eat.
Right. But the fixed monthly all you could eat is, look at that from an Azure perspective. Let's say they came to you and they said, all right, Jeff, you're going to pay us $120 a month and you get unlimited access to Azure. You get unlimited service in Azure.
Well, not all of Azure, but for a resource. I mean,
Right.
You can see where if I pay some amount per month and it's a job that, well, it's going to run for as fast as it can nonstop.
Right.
Then I think that's appropriate for some applications, where other applications would say, no. If the customers are here, I don't care how far you need to scale. We got to deliver all of those Domino's pizzas.
Right. Well, I think websites, if I had to look at things from a main perspective, I think websites will eventually follow that model to where you'll pay a monthly fee, and then you'll be able to run as many websites as you want in Azure, in a given amount of realm. I don't know. I mean, when I look at things from the perspective of a utility, I think a lot of our utility structures have been struggling with how they want to bill. And that's simply because of our old school, right? We were of the things that we always wanted to know what our budget was. We wanted to know that we paid $60 for cable, $100 for cell phone, blah, blah, blah for this. We've been unable to get the masses to understand the utility model and what it means to pay for what you use. Just think if cell phones went back to that, to where you paid 10 cents per minute that you used. Some months you'd be high, some months you'd be low.
Nobody wants to be surprised.
Exactly. And that's kind of the big thing where a lot of these things from a utility perspective have really been struggling to do. But then the funnier part behind all of this is that we've had electrical around for how long? Electrical's probably been around longer than most, and they've been on a you pay for what you use forever. And you can get an electrical surprise. You have one, a refrigerator that misbehaves the month, or a pool pump, and you pay $200 or $300 more that month.
Yeah.
We've been bitten by that before. We're old enough to be nailed by that at some point in time.
All right. So we've had the most applications these days are web applications.
Yep.
And if it's a native app running somewhere, then it's probably going to call, at least in some factor, into a web API, or whether web services or REST or whatnot, that's running as a web application. So we have that. Right. We have the offline job, and then we have to store data.
Yep.
So probably every one of our listeners has a SQL Server database in their existing applications, even if they also store files in a file structure and other things. So talk through let's go through SQL Server. How do we put SQL Server into Azure? Because everybody has it.
Right. Well, SQL Server becomes an interesting facet, right? The beauty behind this is, people usually look at SQL based on the server that they have, because they look at it in their infrastructure and they go, I've got this server that's, 64 core, 96 gig of memory, and I have, 10 databases on it that run it. In Azure, it's kind of flipped on its side. You don't look at the Azure server in Azure as a physical server, because it has no resources. It is simply a container for you to put your databases under. Now, what ends up happening is that you assign resources by the instance that you're moving up. Now, the reason this becomes an interesting talk is Microsoft introduced elastic pooling a while ago, which kind of made things a wee bit more interesting from the perspective of that followed more of the internal model, right? So your internal model was you had 10 databases that shared this resource, right? Now, elastic pooling is that same thing. You now assign multiple databases to that pool, and then they get priorities based on that. So you can drive down cost versus you pumping out one database at a time for a single instance. Now, it did get a lot more interesting probably about 2-3 years ago when they sent out managed instances, which were now the point that I could take any internal SQL database and move it to Azure. It didn't have to be the latest and greatest. I could take a SQL 2003 instance and move it out to Azure, and it could manage it in that way without having to stand up a server like you normally would. So like I say, I think they're figuring out things to hide the implementations of server, because you and I both know that behind the scenes there is a server there running that database just like it always has been. It's just kind of, the evolution of how things are being driven by what they're discovering from usage in the cloud. I look at elastic pooling to save, situations to where you have a dev, a QA, and a production site, right? And you want to put them under one shell, then you can create an elastic pool that'll save you money rather than generating an instance by each that's an S2, S3, whatever, that can come at a much larger cost. So really, moving to Azure and picking out something from a SQL data structure, don't try to map your direct server to what your instance is. Understand what your instances use, and then only give them as much space as they need to in Azure. And then look for options where you can use elastic pooling for, databases that may not be as critical, or that you want to, be able to share resources amongst them, if that makes sense.
Yeah, there's a limitation that we ran into a few years back that caused us to really learn and implement it intimately, which is the DTU cap or the ceiling. Depending on the size of the database and the DTUs that you select, we had one customer database that ran fine locally on a fairly small server. We put it into SQL Azure, and then some of the queries would run dog slow. Well, we go in there, and it turns out these were the queries that were missing some critical indexes, or the query was malformed in some way. And so refactoring it to apply the appropriate indexes and then refactor the query so that it was more efficient, then it was fine. But locally, when you had a server in their data center, that SQL server had access to 100% of the CPUs and memory. And so it was able to overcome the bad queries or the missing indexes.
Yep.
But SQL Azure, I guess because of how they structure it with so many customers, they want to make sure that one customer doesn't overwhelm the infrastructure. And so there's a cap. So that it doesn't overcome your bad query. You actually have to make sure that you've tuned them all out.
Exactly. It's called noisy neighbor. I believe they refer to that in Azure as noisy neighbors. And that's kind of one of those big things that, like I said, everything is not always a good candidate for Azure, but you definitely need to start making sure that you're tuning things and that you're doing it, especially from a data perspective. Azure can overcome a lot of things, and, you can go out and put bad queries and bad databases out there, and you can crank the DTUs up to the nth degree to overcome the problems. But is that really what you want to do? When you have a point where you're almost at, the quote unquote unlimited resources, do you really want to do that? I mean, do you want to spend $10 million a month just to run a database because you haven't, increased your queries or cleaned up data or done something? I sit down with a lot of my customers from a SQL perspective, and I go, what is the average age of your data? Is there data that we can segment out? How do we want to move it? And understand that, moving databases isn't at the gigabyte level, it's at the terabyte level. And you need to understand when to switch to data boxes to move your data out there, because you simply can't do it via conventional methods or an express route or something like that. So there's a lot of things to overcome when you're migrating data out to Azure.
Greg, I feel like we've only scratched the surface, and we may need to do a follow-up show just to get through all of this stuff. But to leave the listeners with some follow-up points, what would you have them follow up on before we close here today?
Well, follow-up points to me would be, review your structures in Azure, kind of look at, how you're doing things, look for opportunities to simplify things. And look for opportunities to gain performance in Azure. So that's going to be kind of the big things I think everybody should follow up with. And then second, also look at how you manage things. Look at things like management groups and things like that, so that you can help control security via a central access point. Use your monitors, use your security centers the way that you should, because these will help tune your applications at the end of the day. A lot further than, you having to keep an eye on them all the time. So, those are some things that I could leave them with.
Awesome. Well, hey, Greg, this is a lot of great information. Thanks so much for being with me.
All righty. Thank you, sir.
And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.